The first section is numbers, and in numbers, I'm sure you know what positive numbers are, negative numbers. I'm sure you know what integers are. I hope you know what prime numbers are, but let's just touch on them really, really quickly. So, positive numbers, which are 1, 2, 3, 4, 5, etc. So basically, it's any number which is greater than 0. So a positive number is a number which is greater than 0. And similarly, a negative number is any number which is less than 0. So some examples are -1, -2, -3, and so on. And it's any number which is less than 0. Then we've got our prime numbers, which I've explained in a different video. But prime numbers are any numbers that can be divided by itself and 1, which is what you've probably been told. But then a lot of people get confused about the number 1 itself. Is that a prime number or not? And the answer is that the number 1 is not a prime number. It only starts from 2, and then you've got 2, 3, 5, 7, 11, and so on. So the actual definition of a prime number is that it's got 2 different roots. So what do I mean by that? Now, let's just show you here. If we've got 2, it's got the 1 as a root and the 2 as a root, as in factors. And if you've got the number 3, then you've got the number 1 as a factor and number 3 as a factor. But if you've got the number 1, yes, it can be multiplied by 1 times 1, but this is the same number. It's a repeated factor rather than 2 distinct factors. So that's why 1 is not a prime number. And then moving on to square numbers, I'm sure you know, but square numbers are just any integers multiplied by themselves to get you a answer. So 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, and so on. Now, what's really interesting is we also know the rules of negative multiplication. So -1 times -1. So the negative multiplied by a negative gives you a positive. So we get a +1. -2 multiplied by -2 will give us a +4. So what we also realize is any integer multiplied by itself will give us only positive numbers. And these positive numbers, they are all square numbers. So these are square numbers. And then there are integers. So integers are whole numbers. So it can be 1, it can be 3, it can be -4, it can be 5,800. It can be any number, but just not decimal numbers or just not fractions. And that leads us quite nicely to fractions, percentages, and decimals. So what are they really? And we know that they are parts of a whole. So if you have 4.4, you know that it's bigger than 4, but it's smaller than 5. So it's 4, and then there's a part of a number which is added to 4 to give you 4.4. And we all know that if it's 4 plus something, which is x, and it gives us 4.4, then we know that that x must be 0.4. So we know that we can write 0.4 as 40% and also as 4/10. So what really is the difference between fractions, percentages, and decimals? Because mathematicians, and you might have heard this from your teachers, mathematicians are very lazy. And it's not lazy in a bad connotation, but mathematicians are very efficient and they like to work out a shorthand, like a quick way for everything. So why would they have 3 separate things for the same thing? And they're very similar, but there is a difference. So we all know that percent, the word percent, is literally made up of per and cent. So cent is referring to 100 and per is out of. So when we say 40%, we actually mean 40 out of 100. So in a percentage, the denominator is always 100. Now, in a decimal, so in decimals, the picture's slightly different because you always have the denominator as 1. So it's 0.4 out of 1. Now, we don't ever write it in this way because anything divided by 1 is itself. So you wouldn't write 0.4 divided by 1. But we do know that in terms of decimals, and especially when we're looking at probability, which we'll move on to, but you've got 0 as the lowest and you've got 1 as the highest, and then you have like a sliding scale in between, and 0.4 will be somewhere here, but it just refers to how the decimal in a sense is always having a denominator of 1. And then you've got the fractions. Now fractions can have any number as the denominator, so that's that. Now we've got fractions, decimals, percentages. I think we should also move on to powers and orders and indices and BIDMAS, because that's really, it's almost like the grammar of maths, right? So like in English, you're not going to say ate I apple. You'll say I ate apple. So similarly, you can't, like if you move around the different wordings, things can get jumbled and the answer will be wrong. So for example, if you were to say 3 plus 5 times 8 versus so 5 times 8 is the main thing here, which I'm going to put brackets around and I'll explain why it's the main thing. But then if you had 3 plus 5 that you're doing first and then timesing that by 8, we'll get different answers, as we can see. So 3 plus 5 we know equals 8, times 8 will be 64. But then if you've got 3 plus 5 times 8, so we know 5 times 8 is 40, and then plus the 3 is 43. So they are two very different answers. So we have to be really careful. So BIDMAS refers to brackets, indices, division, multiplication, addition, and subtraction. Now, brackets are self-explanatory. So just do what's inside the bracket first before you move on to anything outside the bracket. And then division, multiplication, addition, subtraction, which I'm sure you're aware of. So indices, I just wanted to focus a bit more on this. So with indices, let's look at some of the common rules. So imagine you had 5 to the power of 1. Well, I hope all of you know that it's 5. And then 5 squared is, it just means 5 times 5, which we know is 25. And then 5 cubed is 5 times 5 times 5, which is 125. So all we're doing here is whatever, like if it's 5 to the power of 3, we're doing the 5 multiplied by itself 3 times. Now, what becomes a bit interesting is when we look at negative numbers and fractions and so on with indices. So you can have 5 to the power of minus 1. And when you have this, all it means is the minus, anything to the power of a minus something. So I'll explain the other bits shortly, but 5 to the power of minus 1 just means 1 over 5 to the power of 1. So we know 5 to the power of 1 from here is 5, so it just means 1 over 5. Then if you have 5 to the power of minus 2, it means 1 over 5 squared, which we know is 1 over 25. And then 5 to the power of minus 3, it is 1 over 5 cubed, which we know the answer was 125 here, so it's 1 over 125. So that is just positive numbers, like integers, as orders, and negative numbers, so integers, as orders. Now let's move on to fractions. So it's not really much more difficult, but it's just something we should touch on. So if you have 5 to the power of a half, it means 5 square rooted. Nice and easy. If you have 5 to the power of a third, it means 5 cube rooted, and so on. 5 to the power of any, so 5 to the power of 1 over n, where n could be any number. So n could be 10, it'll be 5 to the power of 1/10. And if that is the case, then it'll be 10th root of 5. But right now we've got n just as a general term, just to show it. So it'll be nth root of 5. So that is the case for fractions. Now, what is the case when you're combining the fractions and you're combining the negative? Well, let's see. So if you have 5 to the power of minus a half, then we get, remember what I said earlier, so if you have negative, it's 1 over. So it's 1 over, but then because we have a half, it's square root of 5. So that's 1 over root 5. And then if you have 5 to the power of minus a third, it's simply 1 over the cube root of 5, and so on. So just make sure that you're comfortable with your indices, with your powers. And then the only other special rule I guess we should cover is 5 to the power of 0. So anything to the power of 0 always equals 1. Now, why is that the case? Have you ever asked your teachers? So let's just unpack it a bit more. So I'm sure, well, I hope all of you know by now that if you have, let's say, 5 squared times 5 cubed, well, that's like saying 5 times 5, because remember what I said earlier. So it's 5 times 5 times, so we got 2 lots of 5s, times 5 times 5 times 5. So we've got 2 lots of 5s here and 3 lots of 5s here. Well, we know that is simply 5 lots of 5s. So like not 5 times 5 as in 25, but it's 5 times 5 times 5, like 5 times in total. So we know that that is the same as saying 5 to the power of 5, right? So now, what have we done to the 2 and the 3? Well, we have simply added the 2 and the 3 to get to 5. So all we've done is 5, and then 2 plus 3 equals 5 to the power of 5. So whenever you're multiplying any number, but it has to be the same number. So it has to be, like here we've got 5, so it has to be a to the power of x, like a to the power of something, times a to the power of y, and then you get a to the power of x plus y. So the a has to be the a in every part, which is what we've got here. We've got 5, we've got 5, and we've got 5. So it has to be the same number for this rule to work. And then similarly, when you divide, so imagine you had 5 to the power of 5 divided by 5 to the power of 3, so 5 cubed, then it's the same as saying, well, I'm not going to write it all out again, but it's 5 times 5 times 5 times, basically 5 times. And then you've got divided, well, I'll just write it out, it'll be easy actually. So 5 times 5 times 5 times 5 times 5, and then dividing it by 5 to the power of 3. So 5 times 5 times 5. Now, we know that we can just look at what's common. So how many 5s are at the bottom? For the denominator, we can see that there are 3. So we just get rid of 1 here, but then we must get rid of the same at the top. So we get rid of 1 5 here, then we get rid of the other 5 here, and we get rid of the other 5 here, and we get rid of the last 5 here, and we get rid of the last 5 here. So at the bottom we're left with nothing, but it's not nothing because it's 1. And then at the top it's also like, how many 5 times 5 times 5 go into 5 times 5 times 5? Well, 1 here and 1 here. So essentially you've got 5 times 5 times 1 at the top, and you've got 1 at the bottom. So the 1s cancel in a sense. So you've got 25 as your answer. But we know that 25 is 5 squared. So we know that this answer is also 5 squared. So what we've done is 5 to the power of 5 minus 3. So 5 to the power of 5 minus 3. And that gives us 5 squared. So whenever you're dividing by powers, then you can just subtract the numbers. And then the only other order that we should cover is if you've got a case of 5 cubed and then all of that squared, then here you'd multiply the 3 and the 2. So it's like saying 3 times 2, which is 5 to the power of 6. And that also makes sense because what you've got is 5 to the 3, so 3 lots of it, and then timesing it by itself, which is what you're doing by squaring. Anyway, the bit I want to focus on is that we spoke about why 5 to the power of 0 is 1, or any number to the power of 0 is 1. So let's think about it. If you had 5 to the power of 3 divided by 5 to the power of 3, then you know that you've got 5 times 5 times 5 divided by 5 times 5 times 5. Well, how many 5 times 5 times 5 are at the top? How many 5 times 5 times 5 are at the bottom? Well, one at the top, one at the bottom in a sense. So it's just 1, which is why 5 to the 0 or 5 to the power of 0 equals 1. So that is powers, orders, numbers more broadly. Now, I hope that you all know how to use these functions. So this is the button here. Well, first of all, I'm using a Casio FX991CW ClassWiz calculator. Yours may or may not be the same. So if I want to do 5 squared, then I can just press this button here, and then it gives me 5 squared. However, if I wanted to do 5 to the power of something, then it's this button. So 5 to the power of, and then I can have any number. So 5 to the power of 5, and then divided by 5 to the power of, let's say, 2. And we know from the rules that we've just discussed, it should be 5 cubed as the answer. So let's see, it's 125, which we know is 5 times 5 times 5. So that is just showing in the calculator, just to make sure that we are doing it correctly. Yeah, so the next part